Welcome back. This is the third video, um, and we're going to look at one last step in this process. Again, this was not part of the homework problem, but sometimes you're going to see this in future homework problems where we want to look at what the step response is. So one of the things we can do is I'm going to create another section break, and in this section I'm going to do, let's say, plot step response for the output velocity. I want to look at the output velocity, angular velocity of the motor. And there's a couple of ways I can do this. I could create another Sims variable, let's say R, which would be our input, and C, which would be our output. We can do that. And let's say we're going to apply a 10-volt input, a step input. So R is equal to 10 divided by S. And I'm just going to comment this 10-volt step input. I'm going to come back up and let's say I really want GW out. I want our output angular velocity, not our angular displacement. And so that means GW out is equal to S times G out. And let me just stop there and run this section and see what we get. I forgot to put a multiply sign in here. Let me clean that up. And again, that's the great thing about LiveScript is I can be troubleshooting my script on the fly and run the different sections quickly to see if I'm making any mistakes. And there is our transfer function. I'm going to expand this out. It's didn't factor out the factor of S. I can do that by the command simplify. And we'll take a look and see what happens there. Again, I'm going to run that section. There we go. That's a little bit better, and it still didn't we with the leading coefficient, but that's really not going to hurt us at all. So now that I have our output transfer function as a function of the input, I want to find out what our output is going to be in the Laplace domain with the step input, and so that's going to be just R times GWO. And this is going to give us the Laplace transform of our output, our step response, well, to a 10 volt step. And I can run that. We get a function. And then finally, the one last thing, I'm going to create small case c, and that is the inverse Laplace of the c, our output. And we can look at that and we can run that section. And there we go. We get a step response. Again, not necessarily the cleanest function. So we can let me clean that up a little bit with our VPA command. And we'll use 3 places of decimal after C and run that section again. And there we see that we have a steady state response of 71.4 radians per second. And this is kind of interesting. And I did an example like this earlier in class. If we look at our solution, unfortunately, MATLAB doesn't multiply it by U of t, but this is really t starting at time greater than 0. We have 2 transients. We have one pole that's going to be located at minus 1.44. We have another pole that will be located further out at minus 50.5. You'll notice that this will be the dominant pole, and this will have a lower impact on the overall response. Actually, I got to look at this. No, actually, this is the dominant pole right here. That's 40.5. This one's way out there at 14,000, minus 14,000. So this is the dominant pole. And this one will really indicate how our step response. Matter of fact, this becomes almost insignificant. And Uh, and that's why we can model that motor without taking into account the inductor. Um, Let me go up into our whole total script and let me make this even smaller. Well, let's make it 0 and see what happens. We might get an error. I'm not positive. I'm going to hit run, which will run all sections, and we'll get a final result. Yeah, see, that 0 gave us some issues. Let me make it 0.1 EE minus 10, which is pretty close to 0, and see if that gives us any problems. It's going to make our numbers a little goofy. Oh, it pushes this pole almost out completely, and really we're just left with what would be our whole transfer function, which would be 71.4 minus 71.4 e to the minus 40.4 t all times u of t, and we can pretty much ignore this term. It's decimal dust for all practical purposes. So again, a good way to look at what's happening in the time domain. I could plot C in the time domain. Let me do that. That command's called easy plot. I do have to put some parameters around C. I think it's going to start time before t equals 0, but let me just run this section, see what we get. Kind of wait for the plot. I don't know if you'll be able to see the plot in the video. Yeah, I'll have to clean up the points on the plot so it runs from 0. But yeah, that's how you would plot the functions and how you manipulate in LiveScript. Have a great day.